Hello everyone. Today's video is on the magnetic field generated by the Earth. It is a very interesting thing. We know from compass that wherever you point the compass, it always points towards north. Did you ever wonder like why such a thing is happening? Like how can Earth's magnetic field change the direction of the compass? It's really interesting. And the another thing about this magnetic field is it kind of protects the Earth's atmosphere from disintegrating. So it is like the sun is throwing away a lot of harmful charged solar radiation towards the Earth. If there was no magnetic field, then the atmosphere would just get ripped off and it would create a problem for life on Earth. What we see in Mars is basically it doesn't have the magnetic field because I would explain like why it's not there. But nonetheless it's a very interesting thing to know, and I'll try to keep it as simple as possible. And it is so just one thing is required to understand this magnetic field. That is just from basic high school physics. You know that when current flows in this direction, the magnetic field is okay. I'll just draw it. So let's say you have a wire. Okay, you have a wire, and if you send the if you connect this wire to a battery and you push the current in this direction. Let's say the current is flowing in this direction. So current is basically the flow of electrons. Okay, whenever you have an electron flowing, you have a current. So for example, if you have an atom, which is a nucleus here, and then in this nucleus you have this electron which is going around. So this moving electron around nucleus would create a current in atomic scale here. But when you have something like wire, then it creates a magnetic field in this direction, points upward. So basically this magnetic field is always in loops. So it'll go out in this direction and come in this direction. So what is this field exactly? So field is basically it's the space around anything, and because of this current flowing in this current going in this way, it is going to exert some fluctuations on the area around it, and these fluctuations are called the magnetic field here. And what this magnetic field does is whenever you place any magnetic material in the near to the current carrying loop, then you see some deflection in this. So let's say the magnetic field is pointing this way. Okay, it's going like this. If you have any magnetic material, let's say the magnetic material is like this, but when you bring it near to the wire, it changes direction like this. So the material would get aligned with this field. That's how I could explain the field. Now if we talk about the Earth, how Earth generates such magnetic field. So this is the Earth, and imagine there's a thin layer of crust on top of this. So this is the surface where we all live, and you have a region called as mantle, which is basically all rocks, sediments and all other stuff, silica and stuff. And in the center of the Earth you have something called as inner core, which is solid iron, which is solid. All the heat is kind of generated from here, and in between you have the molten iron here. So this is the fluid iron here, this is the solid iron, and then you have the mantle, then the crust, and then you stay on top, and then we live on the top. Okay, so this part is very hot, okay, this region. But you can ask, why is this so hot and still be solid? So this is a logical question to ask. If you heat a metal, it melts, right? But why does it is solid? It is because of the fact that there is tremendous amount of force pressure from all directions. So that's why this region gets, due to pressure, gets converted to solid. So this is the region of heat, and this is the molten iron region. Okay, so you know from daily experience that in your home or generally that if this is your room, the hot air always goes up and cool air comes down. It's just because of the temperature. Hot air is lighter, it goes up, and the cold air comes down. So this kind of creates a loop like this, right? So something goes up and something comes down. Something similar happens here. So the hot iron, the solid iron, that the heat flows in this direction out, because this region is cool. And since the molten iron is moving out, the cooler iron has to flow in, which flows like so. There is kind of this loop forming here because of the temperature difference. So there is a huge temperature difference between this point and this point. So there is this loop forming here. That is one reason. The second reason is that this is the let's say this is the center of the earth, and the earth rotates around this axis. Okay, so when the earth rotates around this axis and you have this heat flowing in loops and the earth is rotating, this leads to a complex motion of molten iron like this. So the molten iron inside, it flows like this. A simple analogy would be if you have water in a glass and then you try to stir it with a spoon, you form this vortex in the water. Yeah, you can imagine it like that, though it's not exactly the same, but that would be helpful to visualize. So the molten iron flows in this pattern like this, and this emits out a magnetic field like this here. Like, you know how the current is flowing in loops, you have this. Similarly, when the molten iron is flowing in such a pattern, it emits a magnetic field like this. So you have this magnetic field stretching out in all direction. This is how the magnetic field is created. Now the basic convention is that it starts from here and it ends here. So so in North Pole, it goes inside the North Pole and it comes out of the South Pole and then it ends in North Pole. So now let's say you have a magnet like this, a magnetic needle of a compass, north and south. This will have its own magnetic field. Okay, this will have its own magnetic field like this, okay, it will have its own magnetic field. So when you place this the arrow is in different direction. Yeah, so when you place this needle, like this is the needle, now you twist it in this direction, and when there is a magnetic field around this earth, when you bring it next to the earth, or when you are near the surface of the earth, this magnetic field makes it to rotate in this direction. So it's like the north of the magnet aligns with this line what you see. So it gets aligned like this, and wherever you are on this earth, the magnetic field will always point towards north. And exactly when you're standing at the North Pole, you would see that the magnetic field is the compass will point downwards. Actually, if you place a compass, it will go inside the earth. So that's the beauty of it. And now, how does it protect the earth from solar radiation? Okay, so here we have the sun, which emits all sort of charged particles. These charged particles can just wreck the atmosphere what we have, and when the atmosphere is wrecked, of course the life will not exist. So how does this magnetic field reflected? So basically, whenever you have a charged stuff coming from the sun like this, because of this magnetic field, this will get deflected around it. So when it's something like this, it's get deflected around it. So basically nothing ever passes this region. So earth is always in a protective shell always. And there's one thing really interesting. You know something called as northern lights in the upper part of the in the Arctic Circle. You have the night sky lighting up with green light, blue light. You know, it's called as aurora borealis, right? So what is that? Why do we only see that in the North Pole or in the South Pole? Why do we see only in these places? So it's basically whenever a charged particle comes from the sun, sometimes the particle gets trapped in this field and it travels with this one, and then it comes inside this atmosphere. And when it comes inside this atmosphere, these charged particles, the light that we see, it is light which is by the charged particles, and that's why we have this glowing night sky with different colors. So these are basically the radiation from the sun which gets trapped in in our magnetic field. And the good thing about this magnetic field is that another interesting thing is that this doesn't stay the same direction. So there is something called as pole reversal, and after some time, I don't know how many years, the pole would naturally get reversed, and suddenly this would be the North Pole and that would be the South Pole. And that's really interesting. So yeah, thank you.